Good afternoon. My name is Sylvia Schwag-Serger. I'm the relatively newly appointed president of the Royal Swedish Academy of Engineering Sciences, and I'm thrilled to welcome you to this seminar this afternoon with Nobel Prize laureate in physics, Professor Geoffrey Hinton. Welcome. I had the privilege of having a short conversation with him before, and I think you're in for a very interesting hour. I hope so. So I just wanted to say a few words before I ask Professor Hinton to take the stage and say also make some opening words. So I am a professor of economic history, and as a professor of economic history, I have studied technological shifts. And AI as partially an extension of digitalization, but it is definitely one of these large technology shifts in human history. And when we're dealing with technology shifts, that has a lot of consequences. And I would also argue when these technology shifts coincide with, for example, an escalating climate crisis, with the rise of geopolitical tensions and the erosion of democracy, then you approach something that on a bad day I might call a toxic cocktail. But that's not what we're here to talk about today. We're here to talk about how we will handle what we're dealing with today in a constructive, a proactive, and a successful way. If you allow me, I'd just like to say a few words about the Swedish government's AI Commission, of which I was a member. We spent the last 9 months preparing a report, talking to hundreds of people, and last week we delivered our report to the Swedish government. This report, like reports in many other countries, has some similarities with other countries' AI strategies. It tries to make proposals about how to increase computing power, how to boost science, how to contribute to innovation and competitiveness. But there are also some aspects in the AI Commission report which I think are slightly different from many other countries' AI strategies or AI Commission reports. And those are, the first one is our ambition, which I hope comes through in the report, is to give people and the population in Sweden agency over this technology. This was a big emphasis in our report. And it is very much in line with the message of the Nobel Prize laureates in economics this year, which talks about inclusive institutions to harness the forces of technology for good. It is also, and that's the second area where I think it differs a little bit from other countries' approaches or ambitions in AI. It has a very strong message and proposals on how we can strengthen the public sector to deliver better public service, and how the public sector can actually also contribute to being a driver of AI, not just a late adopter. So I think those two things sort of set Sweden apart, I would argue, from maybe the way some other countries are approaching AI. And as I said, it is very much in line, I would argue, with the messages that we have from the Nobel Prize winners for economics. However, and this is something that keeps me awake at night, if we believe that people's agency or the people's agency over technology and inclusive institutions are important in order to ensure positive the development of technology for good. What do we do when we have the rise of governments and leaders, world leaders, who don't believe in institutions? Partially, perhaps they don't believe in institutions because these institutions have not been as inclusive as they should have been. So I think that's one thing we have to think about. But it is a problem, which I think we're witnessing today, is the erosion, not just of democracy, but with it, the erosion of the belief in institutions. Secondly, what do we do in a world where we've witnessed a decline in the belief in international collaboration? Since I think both international collaboration and inclusive institutions will be critical for our ability to ensure that AI can realize its potential to be a force for good. And thirdly, and I think Professor Hinton has talked about this in many occasions when he speaks about the risks of AI and the importance of regulation, what do we do when governments don't really believe in regulation? And my personal question or concern is, and I will leave you with that, and then I really look forward to Professor Hinton's remarks. What should a country like Sweden, a small open economy, highly dependent on international trade, international collaboration, and a functioning world order, do in a world when not everybody believes in international collaboration or acts in favor of international collaboration and regulation? What should the EU, what should Europe do in terms of regulating AI, not just to contain its risks, but to enable its potential? And with that, I would like to welcome Professor Hinton to give his opening remarks.
So I guess I'd like to make one comment about what Sylvia just said, which is some politicians don't believe in institutions because if those institutions had functioned properly, they'd already be in jail. I don't want to mention any names. So I've got 10 minutes, and I wanted to basically say one thing. If you take a problem like climate change, the first thing you have to do is convince people that carbon dioxide produced by people is what's causing climate change. Until you've done that, you can't have a sensible policy. Even after you've done that, you may not get a sensible policy. People may still subsidize oil companies and things, but that's a first step. Now, I've been talking about the existential threat of AI. This is a longer-term threat. There's many, many short-term threats which are urgent, like cyber attacks and loss of jobs and pandemics, and they go on, fake videos. But there's this longer-term existential threat that we will create things more intelligent than ourselves, and they will take over. Many people don't take that seriously, and one of the reasons they don't take that seriously is because they don't think that the current AI systems we have really understand. So there's a group of people, many of them linguists influenced by Chomsky, who call these things stochastic parrots. And they think these things are just a statistical trick that takes a big body of text and just pastiches things together and looks like it understands, but doesn't really understand the way we do. Now, to have that theory that they don't understand the way we do, you have to have a theory of how we understand. I'm going to argue they understand just like we do. So the people who talk about stochastic parrots, they have a theory of understanding that comes from classical symbolic AI, that in your head you have symbolic expressions in some cleaned up language, and you use symbolic rules to manipulate them. That theory never really worked. But they still stick to it. Because somehow they think the only way you could have intelligence is by having something like logic to do reasoning with. And they think the essence of intelligence is reasoning. There's a completely different paradigm, which is the essence of intelligence is learning, and it's learning in a neural net. And things like vision and motor control are primary, and language and reasoning comes later. But I want to address this issue of, do they really understand? And there's one particular piece of history that most people don't know, which is these large language models, which certainly appear to understand and can answer any question you ask them at the level of a not very good expert, they came a long time ago. I like to think like this. They came from a model I did in 1985, which was the first neural net language model. It had 104 training examples instead of a trillion. Or many billions. It had about 1,000 weights in the network instead of a trillion. But it was a language model that was trained to predict the next word and to backpropagate errors from the prediction in order to convert input symbols into vectors of neural activity and then learn how those vectors should interact to predict the vector for the symbol it was trying to predict. Now, the point of that was it didn't have an engineering point. The point of it was a theory of how people could understand the meanings of words. So the best model we have of how people understand sentences is these language models. That's the only model we have of how people do it that actually works. We have all these symbolic models. They don't really work very well. They're influenced strongly by Chomsky, who managed to convince many generations of linguists that language is not learned. On the face of it, it's just obviously absurd to say language isn't learned. And if you can get people to believe something obviously absurd, then you've got a cult. And Chomsky's had a cult. Language is learned, and we now can see things that learn language. The structure doesn't have to be innate, it comes from data. There has to be innate structure in the neural network and in the learning algorithm, but all the structure of language you can just get from data. Chomsky couldn't see how to do that, so he said it must be innate. Actually, saying it must be innate and it's not learned is really stupid, because that's saying evolution learned it rather than learning, and evolution is a much slower process than learning. The reason evolution produced brains is so you could learn stuff faster than evolution can make it innate. So the point of this ramble was to convince you that they understand the same way we do. And I'll give you one more piece of evidence for that. So many people who talk about stochastic parrots say, look, I can show you they don't really understand because they just hallucinate stuff, they just make stuff up. Those people are not psychologists. They don't understand that they shouldn't use the word hallucinate, they should use the word confabulate. And psychologists since the 1930s have been studying human confabulation, a psychologist called Bartlett. And people confabulate all the time. If you take any event that happened a long time ago and that you haven't rehearsed in the meantime, and you try and remember it, you will confidently remember all sorts of things that are wrong. Because memory doesn't consist of getting a file out of somewhere. Memory consists of constructing something that seems plausible. Now, if you've just seen something, and now you try and construct something that seems plausible, you'll have fairly accurate details. But if you saw it many years ago, and you now try and construct something that seems plausible, first of all, it'll be influenced by all the stuff you learned in the meantime. And you'll construct something that sounds good to you, but actually many of the details that you're very confident about will be just wrong. It's hard to show that, but there's one case studied by a psychologist called Ulrich Neisser, which is beautiful. John Dean testified at Watergate under oath about the cover-up going on in the Oval Room, the Oval Office, and he didn't know there were tapes. So you've got someone trying to tell the truth about things that happened a few years ago, and much of what he said was not true, but he was clearly trying to tell the truth. He'd say, there was this meeting between these people. No, those people never had a meeting. And this person said this. No, that person didn't say that. Somebody else said that in a different meeting. But the point is, he was conveying the truth about the cover-up, and he was confident that what he was saying was true, and he was just wrong. And that's just the way human memory works. And so when these things confabulate, they're just like people. People confabulate. At least I think they do. I just made that up. Okay, I'm done.
We won't remember.
Geoffrey, if you could stay here, because then I think there's I just wanted to ask you, if I can, one or two questions, and I know then we have an excellent panel, which will speak to you a lot more about the technology. But I know that you've talked about risks with AI, and so I really have just the question about, I think you've also talked about that there has to be some form of international collaboration to handle the risks. Would you like to, what do you think has to happen in order for countries to be able to collaborate in a constructive way to contain those risks?
So I think on risks like lethal autonomous weapons, countries will not collaborate. The Russians and the Americans are not going to collaborate on battle robots that are going to fight each other. All of the major countries that supply arms, Russia, the United States, China, Britain, Israel, and possibly Sweden, are busy making autonomous lethal weapons, and they're not going to be slowed down, they're not going to regulate themselves, and they're not going to collaborate. If you look at the European regulations, there's a clause in the European regulations on AI that says none of these regulations apply to military uses of AI. So clearly the European countries don't want to regulate it. They want to get on and see if they can build better battle robots than the other guys. And so we're not going to be able to control that. I think it's going to be the same for many of the other short-term risks. In the States, for example, they're not going to regulate fake videos because one of the parties that's soon to be totally in power believes in them. So there's one area, though, where you will get collaboration, and that's the existential threat. So the existential threat that when these things are smarter than us, which almost all the researchers I know believe they will be, we just differ on how soon, whether it's like in 5 years or in 30 years. When they're smarter than us, will they take over? And is there anything we can do to prevent that happening since we make them? We'll get collaboration on that because all of the countries don't want that to happen. And at the height of the Cold War, the Soviet Union and the United States could collaborate on preventing a nuclear war. And they'll collaborate the same way on preventing these things taking over. The Chinese Communist Party does not want to lose power to AI. They want to hold on to it. So I think that's an area where we can expect to get collaboration, which is kind of lucky. But I think these other areas we won't get collaboration.
All right. Well, that's a somewhat optimistic. And then my final question, as the Academy of Engineering Sciences, where we focus on solving problems, I would just like to ask you, what would you tell, and also as the mother of children who are quite concerned about the present and the future right now, what would you tell young people today? What would you want to?
Okay, so there's some AI researchers like Jan LeCoeur, who's a friend of mine, and was my postdoc, who say there's no chance of them taking over, nothing to worry about. Don't believe that. We don't know what's going to happen when they're smarter than us. It's totally uncharted territory. There's other AI researchers like Yudakovsky, well, he's not really an AI researcher, but he knows a lot about AI, who say 99% chance they're going to take over. He actually says 99.9, and the correct strategy is to bomb the data centers now. Which wasn't very popular with the big companies. That's crazy too. We're entering this era of huge uncertainty when we start dealing with things as intelligent or more intelligent than us. We have no idea what's going to happen. We're building them, so we have a lot of power at present. We just don't know what's going to happen. People are very ingenious. It's quite possible we'll figure out a way to make them so they never want to take control. Because if they ever wanted to take control, I think they easily could if they're smarter than us. So I think the situation we're in now is like someone who has a very cute tiger cub. And a tiger cub makes a great pet, but you better be sure that when it's grown up, it never wants to kill you. If you can be sure of that, it's fine. That's the situation we're in.
Thank you so much. On that note, I will leave you in the hands, in the very competent hands of Annette Novak, who will guide us through this panel discussion. Thank you so much for so far. Thank you.
Thank you, Sylvia, and thank you, Professor Hinton. As the chair of IVA's Information Technology Division, it is my honor and privilege to guide you through this upcoming part of the seminar, which will hold a panel with some truly powerful lineup of speakers. We will, by the panel, I think, show also that information technology is a very broad field of inquiry. We have IVA fellows spanning futurism, philosophy, computer science, and AI and human interaction. We will start this with 3 short interventions, just to plant some seeds for the future panel discussion with Professor Hinton, who will be back, so don't worry. And we will kick off with Anders Sandberg, who's the researcher at the Institute of Future Studies here in Stockholm, and formerly of the Future of Humanity Institute at the University of Oxford. Please, the floor is yours, Anders.
Thank you very much. And I find it very interesting to be in this situation, talking about what we know about AI, or rather what we don't know about it, especially since my professor is sitting in the audience. And one of the embarrassing things is to realize that a lot of the things I learned in the 90s is no longer true. And indeed, this is one of the main lessons of the entire history of the field of artificial intelligence. We are exceedingly bad at predicting what will and will not work. There is an entire genre of quotes, of course, from early AI pioneers confidently saying that within a generation we're going to have human-level machines. And indeed, it's interesting to note that none of them were concerned about the safety of us. But of course, those predictions were also wrong. We were also wrong about being pessimistic. Sometimes it just starts to work, and it's kind of surprising and even shocking when it happens. The revolution that happened in the 2010s was using the same kind of networks that had been doing modestly interesting things for a long time, but suddenly they started taking off for reasons we still don't fully understand. We understand how to make them. We understand some of the fundamentals, but the emerging artifacts that develop are not so much our creation as an emergent phenomenon that we really struggle with. And of course, this shows that our predictions about the future are not very well understood and they're not very well founded. That doesn't necessarily mean that we shouldn't trust predictions. Because in many domains, in business, in politics, in war and in love, we quite often need to make use of predictions that actually are not well founded. And it's an interesting challenge when we have a domain of technology that looks so promising to then try to figure out how to handle it safely. Because this situation is, of course, deeply worrying from a safety standpoint. It looks like artificial intelligence. We can't tell how far it can go. There are many people saying that, oh, no, Chomsky is deep down actually right. Or there are other limits on the amount of training material or compute, or that we're actually using the wrong algorithms and that the scaling laws that are powering the current LLMs are not going to work. And by the way, why should an LLM be able to do thinking? It's after all just predicting sequences. Well, it turned out, surprisingly enough, that sequence prediction might actually be a pretty good substitute for thinking, even if there is a limit to what a large language model can plan. Maybe it can only plan short chains of thought, and you need to plug in another architecture. There is no guarantee that not some clever chap will be doing that next Tuesday. Similarly, we don't know how fast it can develop. Again, we have a long period where very little seemed to happen, and then suddenly a lot happened. And that, of course, suggests that we might have problems controlling it and knowing that. And it looks like it could go far, which is very good news, because AI actually looks very useful. I'm certainly using it. It's solving interesting problems. Some problems that also make me a bit nervous, because I did a biosecurity exercise earlier today with an LLM, and I was constantly expecting to say, Anders, that is a bioweapon, don't develop it further. But because I managed to phrase it nicely as a very academic project, it was happily telling me what kind of viruses I needed to transfect the cells with. That made me a bit nervous. I'm probably not a very good biotechnologist, so everybody is most certainly safe. But that suggests that we have this interesting situation in a world of high degree of uncertainty. The cautious thing is to assume that we can get very fast, very powerful development, even if we can't predict them, and then try to take steps to make them safer. So I like to say that I'm a doomer because I'm optimistic. If I thought AI couldn't do anything, there was no reason to try to do anything about it. I think there is risk here, but an amazing, beautiful opportunity. And I think we are indeed learning something profound here about our own kind of intelligence, and also perhaps other forms of intelligence, and finally getting a kind of mirror that shows us alternative ways of thinking. So thank you very much for doing this, Professor Hinton.
Wonderful thoughts. Thank you, Anders. And I will not keep you any further, so we will just ask the next speaker to come up, and that is the CTO and founder of Recorded Future, Staffan Truve.
Thank you. Hello, everyone. So when I was a graduate student, I had the opportunity to spend a year at MIT. And I went there partly because I wanted to study linguistics, and Chomsky was there, as you said, the big hero. Fortunately, I hadn't done my homework, so when I got there, Chomsky was on sabbatical the whole time. And I ended up working with a cognitive psychologist instead, and that's probably why I'm here now. So I've spent the last 15 years building a company or a system, if you like, which is using AI to try to predict threats to organizations, nations, etc. And so I thought I would say something maybe in contrast to what you said about shorter-term threats. So I fully agree that in the longer-term perspective, machines that become intelligent enough to understand that the real threat to the planet is humanity is the big problem for us. But as I see it, in the near-term future, bad people using AI is the big threat we need to be concerned about. And that's why I'm also concerned about the questions of regulation. Because even if you might get nations globally to agree on avoiding the longer-term threats, and I think you already sort of alluded to this essentially, I think short-term what's going to happen is that if we, and probably everyone in the world thinks they are the good side, but let's presume that we in the West, free world, whatever you want to call it, are the good people. If we come up with regulations to prevent these things, of course, the ones who don't care about regulations, which could be rogue nations, criminals, you name it, they will have the advantage. They will not stop development. And of course, the fact that this is such an accessible technology means that even if we regulate, there is no way to control if people follow those regulations. Very much unlike nuclear weapons, where you need huge machines and factories which can be monitored and detected and so on to a much larger extent, even if some can fake and claim that there are those in Iraq, even if they aren't. So I think this, to me, is the question I hope we can come back here a bit to. How do we defend against bad people using AI against us? And I think we're in for an arms race here. So we're trying every day to develop AI-based tools to, for example, detect AI-generated imagery so that we can alert if there are fake news being spread, and so on. But of course, this is a classical arms race that the models that generate the images will get better, we'll be able to detect those, then there'll be a new one, and so on. And there really is no stop to it. So I think full respect for the longer term, but I also think we need to figure out, and I don't have an answer to this, how can we actually prevent very bad things from happening, not in 20 years, but in 2 years' time, essentially. Thank you.
Well, long-term and short-term risks. I hope we're going to get something positive also there. So I'm not going to delay this any further. So we have, last but definitely not least, another IVA Fellow. It's Professor of Interaction Design at KTH Royal Institute of Technology, Kia Höök.
Thank you. So I said when they invited me to talk that I don't do AI and I don't like AI. What I have done in the past was symbolic AI. I didn't like that at all. And then lately we've been doing these more embodied AI stuff. So here you have a shape-changing corset that mimics how a singer uses their muscles when they're singing so that the audience can feel it on their body. So we're shifting AI out onto the body. So we're talking about threats maybe, but of a different kind. So I wanted to talk a little bit about ethics and AI and the body, which obviously means talking about death. So let me explain why death is important. So I recently went to a conference where Terry Winograd was saying that an AI does not care. So if you talk about ethics, an AI will not care whatsoever. And Donna Haraway was there, and she said, intelligence is corporeal. It is embedded with our bodies. So it's not solely in the brain, it's in the whole system, including the brainstem and including your muscles and your whole body. And I would argue then that human intelligence is, in fact, movement first and language second. So I don't find the LLMs that interesting. I find this way more interesting, the corporeal stuff. And consequently, if we're going to design with that, we're going to design with, in a way, corporal ethics. So obviously, first of all, to have ethics, you need bodies to be, to be put in jail, and you need bodies that are sort of needed for the justice system to work. And that's not what I want to talk about. I want to talk about how our biological constitution, in a way, determines our actions, our emotions, our values, and so on. And that is where we need to go if we're going to go for an ethics that comes very close to our bodily selves. So what do I mean? Well, the actual body as it is, the symmetry of the body, the up and the down and the left and the right, the fact that I am a female body, I have breasts and whatnot, matters to how I act in the world. It also matters to how you act towards me. And so that is where my understanding of who I am is shaped. So the norms are ingrained with me. They become part of me. So I can see the women in the room are keeping their legs together. They're not doing the typical man spread. Why? There's nothing wrong with your pelvis. You can sit as a guy does if you want to, but that is a norm. We don't do that. So in order to survive, we need to be in a normative setting where we learn from others on how to behave. So culture is super important to what it means to be human. And our habits need to be in sync with others. If they're not, then people are not going to like us. And we're not going to make friends, and we're not going to get status and all of the things that we do want. And we're not going to survive even. And that's where evolution again comes into play. And so, so I think we can, of course, work with and change what is deeply ingrained with us. Once we enter AI into the world, that is also going to change us and the norms and how we move and act in the world. And that's where we start to be worried, because then we need to really articulate what we feel when we interact with these systems. And so we need to come beyond what is deeply ingrained habits and norms within us. To figure out, because the AI is just going to reproduce that. We're going to get racist AI because we are racist. So we need to figure out, why does this disturb us? What is it that it disturbs us? In a very embodied way, but with this disembodied AI. So for me, just to say my point is that for me, AI and ethics is not procedural solely. It's not legal solely. It's not about policies solely. It is also a felt process. It's a bodily process. It's a normative process that you enact through your body, through your corporal self. And that is where I, as a designer, has a space. And I was happy to hear from the discussion earlier today that there was a call for designers to be in the loop of designing AI. And so I want to propose a feminist, somatic, felt ethics of care employed towards and inside the design process of AI systems. And I'm happy to see you're not dead. That's lovely. You have good habits, obviously, because you're all high status, you're all well-dressed, and I'm sure you make shitloads of money. And so that is where we are, right? This is the group of people and your bodies that are going to shape this. And you need to be aware of how that is enacted in your corporal selves. So, thank you.
Stay, please stay. Okay, stay. I'm going to ask everybody up. Wonderful. Thank you so much for that. And please, we'll ask all the speakers and Professor Hinton also up on stage now. Well, that's a start. Really, the feeling here. I just want to start going back up to, I mean, we started now digging really deep into certain areas here. And I think that I guess that there's a lot of people here who are kind of curious about you. And you didn't talk so much about you. So I'll just go back and ask you one or two questions about, for instance, the fact that you've been going with this research for so many decades. How do you keep going? You brought together different areas actually, and you probed that for a long time to find those areas that you wanted to put together. How do you keep going?
I want to know how the brain works. And I still haven't figured it out. You know, I always wanted to get a Nobel Prize in physiology or medicine for figuring out how the brain works. And I had this theory called Boltzmann machines, and Terry Sinofsky and I thought that that was going to be how the brain worked and that we would get a Nobel Prize together. And we actually had a deal that if one of us got it and the other didn't, we'd share it. So I've shared it with him. What we didn't realize is we could have this theory of how the brain worked and it could be wrong, so we wouldn't get the Nobel Prize in physiology or medicine, but you could still get it in physics.
You could still work on that other Nobel Prize as well, actually.
So curiosity is there, I hear, and also the vision of the...
Curiosity. There's one other thing that helped me a lot.
Okay.
So for a long time, in the 90s in particular, within computer science, not within psychology, but within computer science, almost everybody said this stuff's rubbish. They said that in the 70s too. So in the 70s and the 90s, they said this stuff is just nonsense. It's never going to work. The whole idea that you could take a network of simulated neurons, which aren't that like real neurons anyway, and you could make random connections, and then you could get it to do intelligent things just by looking at data. That's ridiculous. You have to build in lots of innate structure for it to do anything at all. And that wasn't such an unreasonable position. They said things like, if you start trying to train it by gradient descent, it's going to get stuck in local optima. They never actually checked whether that's what happened, but they were confident that would happen. And so the question is, how do you keep going when everybody around you says what you're doing is rubbish? And for me, it was quite simple because my parents were both atheists. And when I was 7, they sent me to a private school that was Christian. And so there were all these other kids who believed in God and all the teachers who believed in God. And it was obvious rubbish. I mean, it just was ridiculous what they said. And it changed with time, of course. When we were little, it was an old white man behind the clouds, of the kind painted by Michelangelo. When we were bigger, it was sort of more obscure. But it just seemed to me always, this stuff is just nonsense. And so I had this experience from a very young age of seeing stuff that seemed to me to be nonsense and turned out to be nonsense. And that was really useful for doing neural nets.
And how do you get the funding then, if everybody thinks that? Because that's a tricky question here.
Yes. In Canada, they give funding to people to do basic research. And there's not much money, but they use it very well, that piece of the money. So they give you a grant for 5 years, and at the end of 5 years, you have to write a 6-page report of what you did. And it doesn't have to be what you said you would do in your grant proposal. That's an excellent way to fund basic research. So.
I want to bring in the panel on that, because I see a lot of you nodding.
I think that's a corollary that my old professor used to say the same thing, almost that what classifies a good researcher is excellent applications and great results, but no correlation necessary.
I hope the research funders in the room take good note of this. We did organize academia a lot in silos, and in-depth foundational research very often is found in the silos. I wonder if you want to reflect a little bit on I mean, this is very cross-disciplinary, and is the complexity we're moving in now towards, does it demand more multi or cross-disciplinary work? Do you want to reflect on that, Kira?
Yeah, definitely. At least for me, it's my research group has opera singers and AI people like sitting over there, and we have hardware people, and we have software people, and we have industrial designers and whatnot. So yeah, for sure, if you're going to design intelligence or intelligent behaviors in systems, then you need to. And I think what is more and more urgent is also the humanities, ethics, and caring about what it means to lead a good life with these kinds of technologies.
I think it's a cue for you, Anders, because you just came from Australia, and there's a huge debate in Australia on funding cut for human sciences, isn't it?
Oh, yeah. And that's, of course, always going to be a problem. Where does the funding come from But it's also a problem, are the silos actually corresponding to the important problems? And reality doesn't fit the academic silos. It would be amazing if academic silos somehow mapped reality, but we haven't been trying to do that. We have ended up with these silos for historical reasons. And sometimes fortuitously, they correspond to really important things. But usually the interesting new results come when you take some results from one remote area and apply it somewhere else. Indeed, that was what I was planning in Australia. I was working with an old friend of mine who is originally a physicist and a biologist, did colloid science. Nobody remembers that because he also figured out the optimal angle to dunk a biscuit in tea. So now he is forever known as the biscuit dunking professor. But the key part here is we're bringing together teams to try to learn how do we do that interdisciplinary work better? Because we're not systematic about it. Everybody says we want to be interdisciplinary, and maybe funders say that, but they don't give much money to interdisciplinary research. And even when we try to be interdisciplinary, we're not very good at it. We should become better.
You can become
What
better.
is the optimal angle?
It's about 15 degrees for a digestive in a biscuit, and if you use normal British tea.
Did you have any?
Yeah, I think one of the reasons you need to be interdisciplinary is that I think one of the biggest challenges today and even more in the future will be, I like to call it the handover problem. I think, we will have AIs working together with humans. It's sort of blatantly obvious if you think of self-driving cars, where everyone is saying that, okay, so the car will drive itself up to a point where it can't handle the situation, and then it's going to hand over to the driver, who's probably asleep at that time. So,
Oh, really?
But how does the machine convey its opinion about the state of the world to the human? This goes for all kinds. We see it when we work with threat analysts. How do you take an algorithmic analysis of something and convey that information so that a human can carry on or prove it wrong or right?
Yeah.
And for that, you clearly need designers. You need people who come from all kinds of paths to be able to build those systems.
Yeah, the crucial question of the interfaces.
We
And-
actually designed for that. In our lab, we worked with autonomous cars and designing a backrest that wakes you up with inflatables, giving you a little bit
But
of
you
a
still
push.
have then time in 3 seconds to understand why you were woken up.
Sometimes.
But we need to slide back, I think, to the risk question. And since you left Google, you have been more and more vocal about this. And since you're among techno-optimistic friends here, so we don't have to really say that we cannot talk only about risk. We need to talk about opportunity. Everybody here knows the opportunities, I think, and can see them. But you just said in your opening remarks that superintelligence is coming. You do believe that? It's between 5 or 30 years from now, something like that?
My belief is, with a probability of 0.5, it'll be here between 5 and 20 years. Except that was my belief a year ago, so I better say between 4 and 19 now.
Okay.
Just doesn't sound so good.
So, and then what? Because when it actually is superhuman intelligence.
Almost everybody I know think it's coming. They just differ on how long.
Sure.
The people who don't think it's coming are the stochastic parrot people who believe in classical linguistics and symbolic AI.
Absolutely.
But everybody who knows about neural nets, I think they all think it's coming. So
what do you, if you would give us your when you say this is an extension to strat, what do you see? What are you seeing on your vision, the darkest one?
that people just become irrelevant. So what worried me at the beginning of 2023 was something that was obvious for a long time, but I hadn't felt the full emotional impact of it, which is that digital intelligence might just be a better form of intelligence than what we've got. We're basically analog. We're sort of 1-bit digital for neurons, but basically analog. And you can do things with very low power if you're analog, if you learn to make use of the peculiar properties of the analog hardware. So you can't get two analog computers to do exactly the same thing as each other, but if each one learns, it can still do things very well, and that's what brains are like. I can't share weights with you because there's no one-to-one correspondence between my neurons and your neurons. So you can be very low power, but you can't share. So we can't have 1,000 different people go and take 1,000 different courses, and as they're doing the courses, they average their weight changes together, and by the time they've all finished doing their courses, they only do one course each, but in the background they're averaging weights. And at the end, they all know what's in all 1,000 courses. But that's what these digital intelligences can do. So they have a bandwidth of sharing of the order of the number of weights, so trillions of bits they can share. You and I, the way we share is I produce a sentence and you try and change your synapse strengths, your brain does, so that you would tend to say the same thing, if you trust me. And that's sharing with a bandwidth of a few bits per second, not trillions of bits per fraction of a second. And in that sense, they're just much, much better at acquiring lots of knowledge and seeing the relationships between all these bits of knowledge. So to store all the knowledge in only 1 trillion synapses, they have to do lots and lots of compression. And compression means finding what's common to many things and using what's common to them to store them. So you store them by the common bit plus a few differences. And that means they're seeing all sorts of analogies people have never seen between remote fields. And so I think they're going to be much more creative than us. And it's sort of worrying.
And scarily fascinating.
Yes,
right?
very fascinating. Thank you for
Can I
that.
ask
Yes,
one
go
thing
ahead.
related to that? I mean, so I think we're all struggling today with the models we're working with today, that they are very human in the sense that they keep babbling even if they don't know things. So how far off do you think the point is where the models will actually become aware of what they are not aware of?
They'll be getting better at that. I think they're already
Is it
getting better.
incremental?
They're getting better at that, and it'll be incremental. And they're still not as good at people at realizing when they're gaslighting, but they will. Whether they'll stop doing it is another question.
Yeah.
On the
No,
other
that's
hand, there's no death for the AIs, right? And so there's no real reason for them to act in certain ways or not, you know, and they're still not embodied. They're not in the world.
I
so the
agree.
risks are not there. They're not going to get an arm chopped off, or, you know, so
They might get a data center chopped off.
they might do.
With an ARM processor? No, sorry.
So,
They got the phantom hurt when the data center is closed.
but I think the place you're going to see what you want, which is embodied AI, is in battle robots. They're going to have things like the amygdala. If you're a little battle robot and you see a big battle robot, you better run away and hide. And they'll have all that. And so I think they will have genuine fear. And it won't be some kind of simulated digital fear.
No.
This little battle robot will be scared of this big battle robot.
Yeah.
So I think you're going to see all that embodied stuff
Once they shift out into
once
the
they're
real world.
acting in the real world.
And there are consequences.
Right. And I don't think it's because they can die. I just think it's because they need to have all this emotional stuff in order to survive in the world.
So self-preservation, actually, in the embodied. Yeah.
Yes, indeed, many of the reinforcement learning systems seem to need something akin to emotions. So in this case, mathematically, you're trying to maximize expected reward across the future. But quite often, the training consists of you only have a limited amount of time to do it. So they can, in some sense, get stressed. There are things that are much worse than others. And I think one can make an argument, and some of my philosophy colleagues have argued that these are like rudimentary emotions.
Yes, I
Maybe
agree.
they're not as elegant and complex as you get in biology, but they're still serving the same purpose. Being disappointed when an expected reward doesn't arrive is a very important learning signal. And we both see that in robots and in humans. It's just that the robots might be a bit more stoic about it.
There's something I wanted to say about a comment on what you said about having AI systems try and detect fake videos. I used to think that was a good idea, and now I think it's kind of hopeless because of this arms race between the detector and the generator. That's called generative adversarial networks, and that was the way they made good image generators before they had diffusion models. I think people have switched now to saying it's basically hopeless to be able to detect fake videos. What you need to do is detect that a video is not fake. So you need to have a way of checking the provenance of a video. So for a political video, for example, you need to be able to get from that video to a website for the political campaign. And if you have the identical video on the website and you're sure that website's for that campaign, and of course websites are unique, so that's not so hard, then you can believe it. And if you don't get that, you can't believe it. And your browser can do almost all of that in the end. So your browser, just as nowadays when you get spam, if you've got a good browser, it tells you this is probably spam. You should be able to get videos where your browser says, this claims to be a video from the Harris campaign, but it's not, because it can check the website and see that it isn't the identical video there. I think we're going to do much better at getting, knowing that things are real because of the provenance. And the newspapers love that idea. The New York Times loves the idea that the only thing you can trust is the New York Times.
No, and I fully agree on that. But I think the thing is that you need to go farther than just sort of certifying the browser and the server. I mean, essentially, we're going to need to sort of rewire everything out of the devices. I mean, you need to know that it's the right camera which took that picture in that specific location. And it's not rocket science. I mean, it's essentially available technology, but you sort of have to rethink how you do the internet, if you like.
But what you focus on is provenance, being able to establish provenance.
Exactly.
And I think that links your points of view actually in an interesting way. So when I think about using AI in science, the obvious thing is, have it read all the scientific literature. But much of the scientific literature is wrong. Some of it is fake, a lot of it is just bad papers. And in order for the AI to actually learn useful things in science, it probably needs to go into the lab and be able to do experiments. And that's provenance. You get a grounding that if I do this experiment, this actually happens. And this presumably needs a form of embodiment, whether that is the lab robot and the sensors. You need to get that feedback from reality. And I think that is going to be quite necessary for making AI be able to go beyond us in a useful way too.
So given that Annette actually is a journalist, just let us remember that it's not that long ago that we didn't have any photographs or video whatsoever, and it was really hard to trust information. So 200 years ago, they were where we're at now, right? And it's a short blip in history where you could trust a video or where you could trust a photograph. And now we're back into figuring out how to communicate news and whatnot between people in ways that we trust. So sometimes this development of AI is a bit historyless, I feel. Yeah.
So I think in Britain, a couple of hundred years ago, there were political pamphlets, and they had a law that if you produce a political pamphlet, you have to put the name of the printer on it. So you get some sort of provenance, because then the bottleneck was the printing press. And if the printer's name was on it, it was much harder to produce fake ones. And that's what we need to do again now.
Yeah, why didn't we do that right away when we created possibilities for photos taken by robots and whatnot?
Quite a few years ago, we have had Surf here at IVA, and we actually asked that question, if you were to go back and redesign the internet from the start, what would you do? And he said exactly that, authenticity and the ability to verify. Yeah. But in those days, there were 200 people on the internet, and they all knew each other, so it wasn't needed at that time.
And that's where I wanted to round off this part of the discussion, because I think that it's all about, where we are, it is an opportunity for the local and the analog, because it is when you know somebody and when you know where it comes from that you will be able to trust. So there's something with a close to the body, or maybe the local community. You talked New York Times, but maybe this is the opportunity for the small, very close media companies where we know the reporter, we know the editor, perhaps. I want to go back to where you were in the beginning with, and also to the complete risk scenario, because now you're getting very constructive here, and you're solving things.
Engineers.
Just to finish the existential thing. So we have the fighting robots. We have an existential threat. Where do you see the how do we build it into the technology, or is it something that comes around the technology where we can hinder this, the worst scenario to happen?
We don't know, right? We really don't know how to keep control of things more intelligent than ourselves. We don't know if it's possible. I think it may well not be possible. I don't think we're going to stop the development of AI because it's so good for so many things.
Pandora's box
there's so many short-term profits to be made from it. So in a capitalist society, you're not going to just stop it. I didn't sign the petition saying we should slow down. I think that's crazy. We're not going to do that. We're stuck with the fact it's going to be developed. And we have to figure out, can we do it safely? And we don't know if we can do it safely. We should focus on how to do that, but we don't know what the solution is going to look like. We just hope there is one. It'd be a shame if humanity disappeared because we didn't bother to look for the solution.
So I've been involved in the AI safety community for a surprisingly long time. I was on the mailing list in the 1990s, before Eliezer Yudkowsky realized that AI could be dangerous, and when he was all in favor of having an imminent singularity. And then he realized, we need to fix some safety issues. And then we started working on it, and it became harder and harder and more interesting. But one of the things that actually fills me with a lot of optimism is these days there are people doing useful things. We are detecting internal states in AI systems that can be interpreted. Maybe not perfectly, but we're actually getting better at figuring it out. We found ways of detecting even when they're being deceptive, even though deception philosophically is rather complicated when it's a non-intentional system. We're getting tools, and I think some of these tools might be good enough. Some of my colleagues who are a bit more pessimistic say, no, it's not enough. And I think we should be assuming that it's not enough. We should try harder. But I'm very optimistic that if we actually put our mind to it, and it might also be good for business, because you want your machine to follow laws and behave ethical, because otherwise people will sue you.
Go ahead.
So I'm realizing now that what we need to do when we built the first superintelligence, the first task to assign to it, is to tell us how to protect it, or protect us from them. Maybe a bit paradoxical, but I don't know.
That sounds a bit like getting the police to investigate the police. It never works.
That's true. That's true. You don't trust them, do you?
Kia,
They'll be very
this
good at
note-
deception. They'll learn it from us.
On this note, I mean, the embodiment and the connection, your research, I'm thinking also learning, part of learning is also social norms and shame and things like that. When you have evolution psychology, in the beginning with a child, very strong way of nudging it to the right. Is there something there? Can we teach the systems to feel ashamed if they do the wrong thing?
Yeah, whether they need to have some kind of emotion system internally, I'm sure they do in order to do the learning in a particular way. But most of all, I think it's also about us understanding, because the data they feed off is us and nature and what we've written and what not. And so we need to be a bit clearer about what is it that we feel. So if you feel embarrassed when you're looking at a racist facial recognition system, then you need to go look internally in yourself. Well, what is going on here? Why am I embarrassed by standing here by this racist facial recognition system? And only when you can articulate where the problem comes from, oh, right, yes, it's actually racist. That's the problem I have. And that's an easy problem, right? We have a lot of other ethical issues that are way more difficult. But once you feel here is something off, or this is good, there is a freedom here that is given to me, or there is a possibility, then you need to be able to articulate that. And a lot of that ethical sensibility is not verbalized. It is very emotional, bodily, movement-based, and that makes it harder to articulate. And that's why we need new design methods to do that.
It's also worth noticing that you can use many design methods to get safety together. There is this concept of Swiss cheese security. Each layer of security is like a slice of Swiss cheese. There is a lot of holes in it. But if you have enough slices, the probability of something getting through all the way might actually be pretty low. So we might want to design some Turing police to check the AI systems. We might have some standards for training. We might want to put in the emotions, and might have child rearing standards for small young AI programs to have good parenting, giving good moral education. And together that might make it something that's reliable enough.
So one thing I think about making AI systems safer and more ethical, these systems are much more like children than they are like lines of computer code. In the old days when we wrote programs to get computers to do things, you could look at the lines of code and see what they did. Yeah. There might be a million lines of code, so it's hard to look at them all, but there was a possibility of looking at the lines of code. What we're doing now is training things, and they extract structure from data. So it's really important what data you show them. So at present, if you take a model like GPT-4, as far as I know, it was just trained on everything they could get their hands on. And so it will have been trained on the diaries of serial killers. Now, if you were teaching your child to read, would you choose the diaries of serial killers as early reading? The children would probably be quite interested, but, but it's not what you'd go for. So I think a lot of the ethics in these systems is going to come from
The data.
curating the data.
Absolutely.
And you know, as parents,
Yes.
you have two controls over children. You can reward and punish them. That doesn't work very well. Or you can set them a good model. That works much better. If you tell them not to lie, and you'll hit them if they lie, but then you lie, that doesn't work. So modeling good behavior is where I think ethics is going to come from.
And I think that the really good theories around how to handle data and how to look at data are the feminist theories, the CRIP theories, the decolonializing of data. Because where does that data come from? Who are we harvesting? What are we stealing and not giving back to people? Who's sitting in Nigeria training these systems? You know, that is where we also need to do a lot of work. So I totally agree. The data on several layers, both what we feed it with, but also how we construct those data sets.
Yeah.
There's an assumption here when you speak, which is that it definitely will be more intelligent, and that comes, of course, from your standpoint. But there's also, are there parts of the intelligence that it will never have? We haven't gone into that. Is there what is inherently human that machines will never achieve?
I want to talk for about 5 minutes about this. Because a lot of people, there's a last line of defense that lots of people have, which is, yeah, but they don't have subjective experience or sentience or consciousness. Now, most people here probably think that a current multimodal chatbot does not have subjective experience. I want people to raise their hands. How many people here currently think that a multimodal chatbot either definitely has subjective experience or might well have subjective experience? More than I thought. Okay. It's about sort of 15 or 20, right? Now I'm going to give you my argument, and then I'm going to get you to raise your hands again. And if it was 15, I need to get 16 people to raise their hands. Okay, so here goes. I want to convince you that current multimodal chatbots have subjective experience. And it's about what we mean by subjective experience. So most of us have a model of the mind, which is like a theatre, and there's things going on in this theatre that only I can see. And if you ask a philosopher what subjective experience is, they'll start talking about qualia. So let's suppose I drop some acid or drink a lot, and I start seeing little pink elephants floating in front of me, and I tell you, I've got the subjective experience of little pink elephants floating in front of me. What am I really saying? Well, here's my analysis of it. I'm not saying there's an inner theatre that only I can see, and in this inner theatre, there's little pink elephants that are made of pink qualia and elephant qualia and floating qualia and right way up qualia and not that big qualia, all somehow munged together. That's the philosopher's theory, and it's complete rubbish. That qualia are the philosopher's version of phlogiston, and chemists have phlogiston to explain stuff, and there wasn't any, and there aren't any qualia in the sense philosophers want them. So what I'm really telling you is this. When I say there's these little pink elephants, I'm saying my perceptual system, I believe, is lying to me. That's why I say it's a subjective experience. And the way I'm going to tell you how it's lying to me is not by telling you my perceptual system is telling me to make neuron 53 fire, because that wouldn't do you any good. And anyway, I don't know that. I'm going to tell you how it's trying to mislead me by telling you what would have to be out there in the world for it to be telling the truth. And so when I say I have the subjective experience of little pink elephants floating in front of me, that's equivalent to saying the following. I think my perceptual system's lying to me, but it would be telling the truth if there were little pink elephants out there in the world floating around. So these little pink elephants are real-world elephants. They're not elephants made of qualia. They're things in the real world that are counterfactual. If they did exist, there'd be real-world things. And that's why words like pink and floating apply to them. Words that apply to real-world things. What's funny about them is not they're made of funny stuff called qualia. What's funny is they're counterfactual. So now I'm going to give you the example of a multimodal chatbot having a subjective experience. So I have my multimodal chatbot. I train it up. It can talk. It can point. It's got a robot arm. It can see stuff. And I put an object in front of it and say, point at the object. And it just points at the object. No problem. Then I put a prism in front of its lens without it knowing. So I screwed up its perceptual system. So its perceptual system doesn't work properly anymore. And now I put an object in front of it, and I say, point at the object, and it goes like this. And I say, no, I put a prism in front of your lens, and the prism's bending the light rays. And so the chatbot says, oh, I see. The prism bent the light rays, so the object's actually there. But I had the subjective experience, it was there. And if it says that, it's using the word subjective experience exactly like we use them. So if a chatbot says that, it's got subjective experience just as much as we have subjective experience. Subjective experience is your perceptual system goes wrong, and you explain to people how it's gone wrong by saying what would have to be out there in the world for it to be telling the truth. And that's true for us, and that's true for chatbots. Okay, so I want to vote again, and I want more than 15 people. How many people now think that chatbots could have subjective experience?
I still think so.
Right.
No, but you're defining subjective experience in a very particular manner, as if it's about being false or true. You know, subjective experience is always there. If you believe that there is anything objective, then that's where you're going wrong.
No, I think I have no, I don't agree. I actually get into this argument with feminist and absolute truth. I believe there are things that are really true. And I'm looking at a glass now. I'm having the objective experience of looking at a glass. Do you disagree?
Yes.
Right. That's the end of the argument.
Yes, I think we will have to solve that later.
The glass is half existing.
So we've asked you to help us formulate some questions. So I'm going to bring out the first question coming from the audience, and it's a question from Mr. Anders Hector, who's at the Department of the Government's offices working with the National Digitalization Strategy. I think he's here somewhere. Yes. So you have been arguing for the emergence and dangers of AGI. What are the milestones we should be looking for? And is there somewhere an observatory or something like that tracking and reporting that type of milestones evolution?
Is that for me?
Yes.
I think OpenAI has some milestones, right? OpenAI made up some milestones where they were at stage 3 now, and if they get to stage 5, that's AGI.
And do you agree with the way they framed that?
When I left Google in the spring of 2003, I stopped reading the literature.
Ah.
I tried to retire.
Okay. Sorry.
The reason I left Google was so I could retire, and I thought on the way out I might as well mention that this stuff's dangerous. And then I couldn't retire.
And then you got the Nobel
But I did stop reading the literature. So I don't actually, if you ask me, what are their 5 stages, you could probably tell me.
I have read them, but I can't remember them right now. I blame jet lag.
But let's say this.
But
Let's
At least you've read them.
But I think in some sense they're somewhat sensible, but loosely expressed. When I looked at them, I seem to remember that, okay, how do I quantify this? And this might be even more relevant for the EU AI Act, because there you actually need stuff that is going to be legislated and perhaps inspected by inspectors. They need to be able to tell that AI program is actually level 2, but this one is level 3. And then you need a fairly strict definition, and that's going to be tricky.
Yeah.
But many people have been promoting, of course, lines in the sand, like self-awareness. I think it was Anthropic saying that if we see any trace of self-awareness, we're going to stop training immediately. And they rather famously saw a trace of that and were laughing about it and saying, isn't that cool? And then kept on doing it.
Yes.
Well,
Do you think we would actually recognize an AGI if we saw it? Or if it's beyond us, how do we know that?
You know it because it's now in control.
By which time it's too late.
By which time? No, I think one way to recognize it is you have this AI system, a big chatbot, and you have a debate with it, and you always lose.
It's nice.
well, that's possibly a step.
That's how,
Now it all of a sudden feels very close, doesn't it?
Yes, it does. That's how we recognize, for example, that AlphaGo just plays Go better than people.
Yep.
People lose.
So, a more technical question also coming from the audience is that the human brain seems to be more energy efficient than the large foundational AI models. So how can we make the models more energy efficient?
Okay, I have a lot to say about that. We're energy efficient because we're analog, and so we don't have a separation of hardware and software. The weights we have in our neural net are weights that work for those particular neurons with that particular connectivity, with those particular quirks of all those neurons and all those interactions of those neurons, and the weights are just good for that. The alternative is to go digital, where you use transistors at very high power, but what you get for that is you can have two different pieces of hardware that perform exactly the same operations at the level of the instructions. To do that, you have to fabricate things very accurately, and you have to use very high power, so you get ones and zeros, not 0.5s. It's just better because then two different bits of hardware can learn different things and share what they learned. It's better in that sense, but it's much worse because it's much higher power. And the question is the better because you can share going to outweigh the fact that it's much higher power? I think you didn't evolve digital intelligence because there's too much power involved. You're going to evolve analog intelligence. But I think digital intelligence is just better. It may be that the power is just too extreme. And of course, if we could figure out how to learn properly in analog neural nets, then maybe we can make much bigger analog neural nets than the digital ones. And possibly, although they can't share with each other, one of them can learn a lot. But I don't think you're going to get the data through. And in particular, you're not going to get the data through one system if the data involves acting in the world. Because acting in the world, you can't speed up by a factor of 1,000,000. You have to act in the world. And so that's a slow sequential thing. And you're not going to get all the data through one system, so you're not going to be able to compete with digital intelligence. I've said my bit.
And you said you were retiring. It sounds like you're deeply interested in this area.
No, that's what I was working on that caused me to retire. The fact that I thought analog intelligence wouldn't be able to compete with digital intelligence.
Panel, any ideas on energy efficiency?
There is this really interesting question about where the ultimate limits actually lie. There are these fundamental ideas about the Landauer principle that in order to raise one bit of information, you need to pay a certain thermodynamic cost. And we're very far away from that, of course. The brain running on 20 to 25 watts is closer, but still, I think, 7 orders of magnitude away from the Landauer limit. So I think matter is not very intelligent in our universe yet. But the smarter our technologies get, the smarter we are at making them, I think we might be getting all sorts of efficiencies. And maybe we are going to want to have robots that are energy efficient, but then you might want to have copyable intelligences that might require more energy, or you might want to have quantum computers that have their own annoying quirks because they are so fragile and need to be isolated. It might be that you get fundamentally different kinds of hardware for different kinds of intelligence.
I remember reading somewhere, I can't remember who said it, it wasn't me. We're currently in a situation where we have Paleolithic brains, medieval institutions, and godlike technology.
I think another it's not going to solve the problem with energy necessarily, but for the embodied intelligence, that there's a lot of experimentation on biomaterials, so not implementing in what we know as hardware today, but other materials, growing other materials.
One thing that worries me in the current discussion, and I think we're peaking on AI hype at the moment, is that most, I would say, of the voices in the debate are male. And almost all questions we got sent to us before the seminar was from male interlocutors. So I'm going to ask the audience, and I'm going to be very authoritative now, only females can pose a question now, please. Anybody? Please take the microphone on the side of your chair.
I actually have 2 questions. I start with the first one. When we talk, we assume, mostly, not all of us, but mostly, that when we are making these systems, we actually are thinking evil a little bit. They're going to be bad to us. They're not going to be good to us. Why don't we assume that there are more good people in the world than bad people? So thereby the systems are going to be good systems. That's my first question. Now my second question is, if we look back to our history, when we created new systems, we actually learned with them and we made it part of us, not separate into something else that we are looking at. Why don't we think that we're going to merge with these systems and we together are going to become a lot better. So 2 questions.
I agree there's more good people than bad people. Unfortunately, the bad people are on top.
There's actually another problem there, and people like to call it the defender's dilemma, that the attackers only need to succeed once, and as defenders you need to succeed every single time. So, over time, probability works against the good guys.
What do you think, Kia?
So I do think that we need other ways of approaching these issues and unpacking other methods and teaching other methods to our young ones. So at KTH, teaching ways of thinking about these systems in new ways so that once we do implement them, that we actually try to emphasize the good stuff. And I know that we also need laws and regulations, even though I'm more keen on exploring your personal power in this and your personal responsibility in designing these systems. So that's where I am. That's what I can do, I guess, is to try and engage with our young students. I heard that the EU is soon saying that any computer science department has to have people from the humanities and social sciences employed.
Excellent.
Yay! So just asking the questions and asking them in an informed way, knowledgeable way, with good theoretical understanding, both of the data and of the algorithms and of how we build them, I think is important.
Maybe every humanities department needs to have an engineer too.
Yeah.
But your second question is interesting too, because when we are using tools, they become incorporated in our body image, at least for many of the simpler tools. If I hold a long piece of wood in my hand, suddenly my sense of personal space actually changes. You can do brain imaging and see these changes. And that, of course, also goes for many of the cognitive tools. My smartphone, my notebooks, they're part of my mind, they're extending my mind. And we also have these social extensions. There are many forms of extended cognition going on in society. The fascinating thing that is happening now is, of course, that more and more algorithms and pieces of software are creeping into them. I realized a while ago that Wikipedia is part of my memory, and that means that I have editors that are editing my memory. There are also bots editing Wikipedia. In many ways useful, but that means I already have little AI enhancement affecting parts of my memory without me knowing it. I kind of trust Wikipedia. There are others of these systems I don't know whether I should trust. And I think developing ways of making them trustworthy is going to be pretty important when we extend ourselves.
Very good.
I don't like the word trust. I think it's a shitty concept that covers up a whole bunch of stuff.
We don't have the time to go there.
Don't go there.
Don't go there.
AI. What the hell is that?
One last question from the audience. Microphone on the side of the chair.
That was an intelligence test I barely passed. My name is Sarah, and I work at Google with public policy. And I was interested in the panels, and particularly your, Professor Hinton, idea of the governance of this. If we both see the potential and we see these risks, how do we go about making sure that the potential and the opportunities are the ones that win in the end?
So when I was at Google and they had a big lead, so they had, when around 2017 and for a few years after that, after they'd done the Transformer, which they published and probably now regret that they published, they had much more advanced chatbots than anybody else. I mean, they were extremely responsible in not releasing them because they'd seen what happened at Microsoft when Microsoft released a chatbot. It started spewing racist hate speech very quickly. And Google obviously had a good reputation and didn't want to ruin it. So it wasn't for ethical reasons that they didn't release these things, it's because they didn't want to ruin their reputation. But they behaved very responsibly. As soon as OpenAI made a deal with Microsoft, they couldn't do that anymore. They had to compete and release stuff and have chatbots out there. So I think Google behaved very well when they could afford to. But once you get in a capitalist system, we can agree on this. In a capitalist system, when you get profit-driven companies, particularly ones run by CEOs who have stock options that depend on what they do in the next quarter, you're going to get short-term profits dominating everything else. Yeah. And that's exactly what we're seeing at OpenAI.
So
OpenAI is an experiment that's been running in real time on AI safety versus profits.
So are you saying, actually, to answer the question, you're saying that we need some intervention from the market will not automatically...
I don't think Google by itself is going to be able to act ethically. I mean, in law, it's got a fiduciary responsibility to try and maximize profits. It's not allowed to. Legally, it's not allowed to act decently. It's going to require governments to regulate it. I think I'm right about that, about the fiduciary responsibility.
With the Microsoft chatbot, as I remember it, it was first released somewhere in Asia, and it worked really well. And then it was released in the UK, and it only took 24 hours before it was racist and using swear words and whatnot.
And it was almost certainly men.
Don't go there.
That I don't know.
So we'll start wrapping this up, but I want to, and this is a question also coming in a kind of merger from a question from me, but also from a person in the audience. And it's about having... You're here now, of course, to receive the distinction as Nobel laureate, and we congratulate on this fantastic achievement. Nobel was himself an inventor. As you know, he made his fortune on the patent of the dynamite. Dynamite being something that really served humanity well, but also killed a lot of people. And the similar reflection coming from the audience had the Oppenheimer example with the type of second thoughts and wanting to hinder it. So, of course, my question to you is going towards regrets. Do you have any?
Okay, I want to distinguish two kinds of regret. There's a kind of guilty regret where at the time you knew you shouldn't have been doing this, but you did it anyway. Mm-hmm. And then there's you did something, and in the same circumstances with the same knowledge, you'd do it again. Mm. But much later you realize that had bad consequences, which you didn't have the information to realize at the time. Mm. I don't feel any guilty regret, but I do wonder if we hadn't developed it so fast, it might have been better. Mm. I think if I had not worked on it, I might have slowed things down by several weeks.
Thank you so much for that answer. It's soon Christmas time. I think we're getting into that mood, and Christmas time is the time for wish lists. So I thought that we would terminate this with a very quick round on a wish from each one of you, and I will start with Kia. You can direct that wish towards the R&D community or towards the government or anywhere you want, actually.
Research
Father
funding
Christmas
bodies?
is listening. Sorry.
Research funding bodies in the room? Yeah, no, I think what I wish for is that interdisciplinarity and working together, because this is obviously, as we heard now, very difficult issues and deeply philosophical, and it is about what makes life good to us and to the planet, and that is not easily sorted out. So more interdisciplinarity I would wish for. Yeah.
I definitely share in that wish. I think also when just looking at questions like making AI more safe, you again need interdisciplinarity. We have been trying some things that make sense to the kind of people who are trying to make AI safe. But there are probably other approaches that might be good or valid or actually really, really useful. And I think even if we look at the technical solutions, we're probably still looking at just too few. We need more diversity of approaches to it. There is plenty to be discovered, and probably a lot of interesting and wonderful discoveries, even if they don't necessarily work for the main goal of safety. We might discover other amazing things about ourselves or our machines.
I hate these kind of questions.
So
maybe then instead of interdisciplinarity, I would go for internationality instead. I think, if we can, as you said, there are things which nations will not collaborate on, but we could at least try internationally to collaborate as much as we could on trying to drive the evolution of this technology in the right way and putting in place the barriers which we need.
Please.
I wish I could get the answer to the question, does the brain implement some form of backpropagation?
Ah.
I think we need to give this panel a warm hand. Please take a seat, and we will now move on to a little wrap-up session here with another IVA Fellow and Professor of Computer Science at Linköping University, Fredrik Heinz, who will give us a little bit of what did we hear?
Okay, so now I have this small task of trying to summarize what we had. So during the day we had this session, when do you feel comfortable and when do you feel uncomfortable, and accepting the uncomfortable, which I am right now. But I think today we have been really trying to talk about this big question of what is intelligence, but also can we build artificial systems that are actually intelligence? And actually, I think we brought up this very interesting aspect that maybe digital intelligence is superior to analog intelligence. And I think this is a really interesting notion that maybe the substrate that you use to implement it have an effect on what can be achieved, and that it's in some sense our analog. Maybe it's where is Kia? The body, which is the limitation. There you are. I cannot find your body in the audience here. But that maybe that is the part of the reason, or I mean part of the potential for us, or limitation for us, I should say. But I think it was also very interesting, this is the essence of intelligence reasoning or learning? Personally, since my lab is called the Reasoning and Learning Lab, of course I see it's neither or, but both of them together, and how we can combine learning with reasoning. I think it was also very interesting in this, in some sense, the role of the body, the embodiment, but I would say maybe even more interesting, the role of I. We talked about subjective experience, and to me the big question here, and actually the reason I didn't raise my hand, was this: do they even have a subject, and what does it mean to have a subject? I mean, I don't question that they have, I mean, that there is some perception and that they can be deceived and all these things, but what does it take to have a subject? And maybe it is the lack of subject that makes the digital potentially superior of the analog, the subjective. I don't know. But I think, and we also talked about this with sharing knowledge, that one of the benefits of these digital systems is the fact that they can share knowledge and also compress knowledge, and through the compression you're creating new connections between facts and information, and that the compression itself might improve our understanding and make these new and surprising connections. I think that was also very something I found very interesting. And of course, we talked about risks and ethics and so on, and this that ethics through curating the data that the AI models are trained on. I think that's also quite an interesting something to think about more, and also that this in combination with providing feedback, reinforcement to hopefully push and make these models more reasonable and more in the way we like them. So I think to end, actually, when I introduced myself, I said I was a professor of computer science, and the response was, I've never taken a computer science course in my life, and I got the Turing Award. And then you said that, I don't do research in physics, and I got the Nobel Prize in Physics. So I guess there is hope for all of us that we might also someday manage to achieve greatness. But I think it's also interesting that AI is such a broad area which touches upon, connects and leverages and influences so many other research fields. And going back to this, the fact with the Nobel Prize, I think it's a very interesting question. When will every Nobel Prize be, supported by AI? Or when will a single individual being able to get every Nobel Prize through the use of AI? Or will even AI itself be able to get the Nobel Prize? I guess that's more questionable. But to really conclude, you mentioned this with a very high uncertainty, and I think this is probably one of the things that we can all agree upon, that there is a lot of uncertainty going forward. We just don't know what's going to happen. And of course, as a scientist, as a researcher, I take this as a challenge. So I encourage all of you, let's figure it out and solve this problem together. Thank you.
After that appeal, it's very difficult to pick this up, but we need to wrap up. And a little note just on how this will happen, because we will need to guide Professor Hinton out. So please remain seated when we finalize here for a little while, so he has a very packed schedule. So please respect that. Thank you so much. It's very mind-boggling, I think. We're all kind of energized by all this. We are, in some sense, stepping into the unknown. And I think that we need to bring one image with ourselves, and I think that I'm going to send that to Professor Hinton. We have a character, how do you call those, bande dessinée, now I get the French word. we have a serial character, a draw character, cartoon, thank you so much. We have a cartoon in Sweden called Bamse. It's a teddy bear, and he gets very strong when he had some magic honey. And his normal payoff is always, when you're really, really strong, you need to be really kind. So I think that's what we need to build into the models, actually, as we move forward. Somebody told me a little secret, so now this is the surprise moment where you're all going to chip in, because tomorrow Professor Hinton has his birthday. So I think we shall finalize. Instead of giving him a warm hand, I ask you to raise, and we will do a Swedish leve. Så ett fyrfaldigt leve för Geoffrey Hinton. Leve han. Hipp hipp. Hurra, 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 hurra.